Alright, welcome to Unit 3, Lecture 2, the basics of rocks. Now rocks, if you remember, make up most of the Earth's crust. It's made up of all those minerals that we talked about back in Lecture 1. Now, a couple little things about rocks. There are 3 major types, major families of rocks. 3 of them. Alright, and the next 3 videos after this are going to be on the 3 major types. First, we're going to start with igneous rocks. And igneous rocks form when magma, which is liquid rock, or if it's on the surface, lava, cool and harden. So this comes directly from magma. Magma and lava turn into igneous rocks. Examples of igneous rocks are basalt, which makes up the oceanic crust, and granite that makes up the continental crust, because both those crusts are made and deposited through magma and lava. The second type of rock that we'll talk about is the sedimentary rock. And the sedimentary rock forms layers, and it gets put on top of the crust. And they come from these little tiny particles of rocks and minerals and organic material called sediments, get broken up into small little fragments and then get compressed or cemented together. So you get layers of sedimentary rock. Sedimentary rock are the rocks with the fossils in it. And as you start digging down into the earth, after you get through the soil, you start getting into the sedimentary rocks, your limestones, sandstones, rocks like that. The third type of rock is the metamorphic rock. Metamorphic rocks are usually found deep underground, and they come from pre-existing rock, so either a sedimentary or igneous rock, that gets altered by either temperature, pressure, or a chemical process. So for the most part, temperature and pressure, it's when they get close to a magma plume, but are not necessarily melted into magma themselves. They just change shape. They change shape, change type. The atoms rearrange a little bit, and you get a metamorphic rock. Now these 3 types of rocks can all be changed from one to another. They're interchangeable. They get changed from one form into another form. And this is called the rock cycle. Alright, the rock cycle is all these processes which change the rock from one form into another. Alright, and they're all caused by geologic forces and processes. And as these forces and processes act, an igneous rock can become a metamorphic rock or become part of a sedimentary rock. And then if that sedimentary rock melts, it becomes magma and solidifies and becomes igneous again. And you can have this happening over and over and over again. So you might be looking at your note packet, and now you see this big empty space. This big empty space is for you to put the rock cycle, because you're going to make your own version of the rock cycle. And you make your own little drawing of the rock cycle. So what we're going to do is we're going to start off. I'm going to use a few different colors here to identify different types of rocks. You don't need to, but you may as well. Alright, up at the top here, this is where I'm going to put my igneous rocks, which are the type made by magma. I'm going to make like a little triangle go in here for the 3 different types. So we've got our igneous rocks, we've got our sedimentary rocks, which I'll put over here, There's our sedimentary rocks. And finally, I'm going to put over in this area our metamorphic. Metamorphic rocks. And each rock type can turn into the others. So let's start with the igneous rocks. For the igneous rocks, they can turn, or they can be formed by either other igneous rocks or metamorphic rocks or sedimentary rocks that melt into magma and then cool back into rocks. If it's a metamorphic rock that melts into magma and then cools, when it melts and cools, it becomes igneous. If it's a sedimentary rock that melts and cools, again, it becomes igneous. And even if we have an igneous rock melting and cooling, it can itself become a new igneous rock. Alright, so you can have any rock melt into magma, cool, and then it becomes an igneous rock. So it's pretty easy one to figure out. Alright, you need the melting and the cooling, and you have the igneous rock right there. Now, how about making a sedimentary rock? Well, again, igneous rocks can make sedimentary rocks, or metamorphic rocks can make sedimentary rocks, or even sedimentary can make other sedimentary rocks. And this comes from weathering, which breaks down rocks, and sedimentation, which is just rocks turning into sediment, small little chunks. So we got weathering, sedimentation, and then a process called compaction. Alright, so you have your weathering, your erosion, your sedimentation. You get little tiny little pieces of rock, and then they get compacted and cemented together to form a layer of a new rock. So in sandstone, you got a bunch of little pieces of sand. Same thing could happen to your metamorphic rock. You can have weathering or some other form of sedimentation, which is again just breaking it into a small chunk. Alright, weathering, sedimentation, and then you have compaction. I gotta use a little shorthand here because I'm running out of room. So that is how you make a sedimentary rock. And again, even another sedimentary rock can be weathered and eroded and become the sediments that it was originally made out of. And then those sediments get moved somewhere else and get laid down in a layer and compacted, and you get a new sedimentary rock from them. And the final type are the metamorphic rocks. And again, igneous rocks can become metamorphic. Metamorphic rocks can turn into other metamorphic rocks. And sedimentary rocks can become metamorphic rocks. And this is a change from heat and pressure. So heat and pressure. And so these usually get formed inside the earth. usually sometimes close to where there's magma, but not enough heat to melt the rock, that the rocks just get changed chemically because they're exposed to so much heat, or they get exposed to so much pressure and change into a metamorphic rock. And so these together, all of this is what makes up the rock cycle. And you can write it any way. You could put the metamorphic rocks on top or the sedimentary rocks on top, just as long as you have the arrows going from one rock to each other rock. So here's a little bit nicer looking diagram, although the words don't always fit. So again, here's the rock cycle. In this case, I have the sedimentary rocks on top. But again, the igneous and metamorphic become sedimentary through erosion, deposition, some kind of weathering processes, and then cementation or compaction. Sedimentary rocks and metamorphic rocks, melting and cooling makes them igneous, and then a change in temperature and pressure, or heat and pressure, make any kind of rock metamorphic. So you can draw it in any way you want. You could search the internet for picture of the rock cycle and get thousands of different images of the rock cycle. Some have pretty pictures, some don't. Just be expected to know the rock cycle and be able to draw the rock cycle at some point in the not too distant future. So rocks themselves, now we know how they form. It depends on how they form as to what class they are. But the rocks themselves have physical properties that are determined, and chemical properties, that are all determined by what they are made out of. They're determined by how they're formed, where they're formed, what formed them. All right? Certain rocks weather or break apart faster than other rocks. Rocks that contain a lot of the mineral calcite lead to rapid weathering, especially when there's acid rain involved. Whereas rocks that are made out of lots of the mineral quartz don't seem to weather as quickly because quartz is a much harder mineral. So the rate, the speed at which a rock will weather and break apart is all determined by the chemical stability of the minerals in that rock. So the minerals in the rock influence how strong the rock is. The metamorphic rock marble is made mostly out of the mineral calcite. All right, and beautiful marble statues that were carved back in the ancient Roman and Greek times now get destroyed if they're let outside or stay outside for too long because of acid rain. Whereas if they were carved out of granite, which is an igneous rock that contains a lot of quartz, those stand through time a little bit better, but might not look as pretty. Now, Bowen's reaction series is a way that rocks come out of magma. This is starting to get into the igneous rocks, which are the first ones we're going to talk about. So Bowen was a scientist, and he looked at cooling magma, and he looked at specifically which minerals crystallize or solidify out of the cooling magma first. Alright, and the pattern that the minerals form out of magma depends on the composition of the magma. So as we have magma, there is, remember, mafic magma, which is low in silica, and felsic magma, that's high in silica. And you can have something in between, or what is known as ultramafic, which is very low, very, very low in silica, and ultrafelsic, which is ridiculously high in silica. And as we go down, if we look at the iron-magnesium minerals, right, olivine, pyroxene, amphibole and biotite mica are the ones that crystallize first, and then the very felsic, ultra felsic rich magma, you get your feldspar, your muscovite mica, and your quartz. All right. Similarly, as you go down, the minerals that solidify at high temperatures are very calcium rich, and the minerals that solidify at very low temperatures are sodium rich. All right, so the big thing about this, I'm not going to ask you to relate this. The big thing to know is that different minerals solidify at different times. It's really this paragraph here. As magma cools and solidifies, minerals crystallize out in a specific order. So if we know what the temperature of some magma is and how it's going to cool, how long it's been cooling, we can predict what kind of minerals are going to crystallize out at what time, and so then we can predict what kind of rock we will end up with. That is the end of this Intro to Rocks lecture. Next lecture, we're going to start talking even more about the igneous rocks. So, as always, if you have any questions, feel free to ask them in class. Please ask them in class. And otherwise, have a good night and see you in class.